look at this question here. This question is taken from NYJC MYE Paper 2, question 6 from the year 2018. All right. So you're told that a game is played. A number of cards is drawn and a single letter printed on it. A player has 10 cards which are A, C. This is a pretty merciful question because it lists out all the letters out for you, the number of letters in order, so you don't need to go and count it out. So I'm just going to list everything down now. So it's one F, then you have got two L's and one W and one more X. Do not forget about that. So before you do any calculation, just count the letters 2, 4, 6, 10 letters. Yes, so it tallies, so you can just move on. Number of different code words they can make, so that's pretty straightforward. Number of code words would just be 10 letters divided by the 2 factorial 3 and 2 factorial. This will give you 302400. All right. Then for B, we ask you for find the number of code words which begins and end with E and which the 2 letters L are consecutive. So it's okay. It just means E is fixed, right? So in other words, there's no arrangement here because E is just E. It's as good as just arranging the one in the middle where L is the same. So you take out two E's and what is left is 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 letters and L's are together. So just group the L together. There's no arrangement for the L as well because you see this as one entity, one group. So you have 1, 2, 3, 4, 5, 6, 7, 8. So this would narrow down to how many entities are there? 1, 2, 3, 4, 5, 6, 7. 7 factorial, right? So 7 factorial. Oh, that's all. I think there's just 7 factorial. There's no other. Yeah, that's all. This is just 7 factorial, which is 5040. Okay. So now C is an interesting one. C is you are asked to find the number of codes such as L are separated at least 2 of the remaining letters. So L has to be separated. So off the bat, L is separated at least 2, right? So means the total number of ways that you're looking at, total number of ways that you're looking at, you just told unrestricted, right? So I think it shouldn't use total. So just number of ways required will just be total unrestricted ways, total number of ways minus of when L are grouped together, right? Together, and when L separated by one letter. Separated by one letter. Okay. One letter. Okay. There you go. So you take the total number of ways. Total number of ways is okay, which is what we found already, which is 3, 2, 4. When L are grouped together, that's the interesting bit. So for this case here, when L are grouped together, when this case here, just this L group. Okay, this one is pretty okay as well. Basically, you need the LL. Then the rest outside you will have how many letters are there? 8. 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have got 3 E's outside and 2 L here. So 3 E's outside, right? So the total number of arrangement would be the entities here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial. Basically, you're taking a 9 factorial over 3 factorial because there are 3 E's outside. Okay, so this is when L group together. Right, so this case here, you check the calculator out. Okay, so that's one. Then we proceed to the next part here. This is L separated by one letter. Now this is a bit tricky because the thing is, okay, the thing is when you're separated by one letter, there are two cases to acknowledge, where whether you're separated by an E or not, you will, because E is the culprit here, your E would messed up the arrangement outside. So what I'm saying is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have got E as such. So let's say this is L and L. If E is here, then you have got two E's outside, right? Okay, so case one is when E is between the two L's. Okay, so this is case number one. So you count the so now you have how many entities? This is 1, 2, 3, 4, 5, 6, 7, 8, 8 entities divided by 2 factorial. The LEL, there's only one way to arrange LELs because they are the same. So or L case two where you're talking about the E 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where L is sandwiched between a non-E. So this is L, this is non-E, yeah, or not E, yeah. Okay, so this one you have got 5 choices, right? Because if you calculate how many non-E's are there? 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4, 5. There are five options. Okay, so outside is left with 3 E's. So 3 E's are outside. In this case here would just be here 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial over 3 factorial times 5. That's it. Okay, this is what I will do. So basically you just take the total number of ways. So number of ways, okay, I'm just going to write it here. It's just 302400, which is the non-restricted ways of 320 minus of when L grouped together, which is minus of 9 factorial, 3 factorial, and minus of 8 factorial, 2 factorial, minus 8 factorial, 3 factorial times 5. Let me check my calculator. Okay, then you get the answer 188106. Okay, there you go. That's how I'll do it. So let's look at the second part. Second player choose 3 players, 3 cards of the first player, 10 cards. Take random. Calculate the probability that 3 cards chosen will all carry the letter E or L. Okay, that's pretty okay, I think. So you're looking at two. Basically the required probability is out of the you need E or L, right? So now the subject now is whether you have E or L. So you have E or L, you group them together, okay, and then the non E or L, okay. So this is how you should think it, E or L, which is 5. You have 5 E or L. So 5 E or L's, 5 of them, and you have 5 non-E or L. Okay, so this case here, you want 3. So basically you're talking about the required probability will just be out of the 5 E or L, you are choosing 3, then total is then choose 3. That's it. So this is 1 over 12. Whereas for B, you're asking for the first player's remaining set card will all carry different letters. Means this guy will pick because in order for you to have same letters, right, means you need to pick up, you're predestined to pick up 2 E's. This guy has to pick up 2 E's and one L. So he has to pick up a 2 E and 1 L. So in other words, I need okay, I'm going to treat all the E's as distinct objects, so that it's easier for me. So from out of the 3 E's, I need to choose 2 E's out because I need to choose 2 E's, and then out of the L's, I need to choose 1. Then choose 3. So this would be the probability they are looking at. Okay, so basically what I'm saying is in order for you to leave the first player 7 remaining cards to have all different, you need to pick 2 E's out and 1 L out. So in order to do that, you just take 3 choose 2, 2 choose 1 over the total away. That's it. So this is 120. That's how we do this question here.